so page 7. And we're still dealing with law of sines, but we're going to be seeing, we call this the ambiguous case, where because of the way that the information is provided in the problem, there's going to be some question in terms of that the diagram is not set in stone, that we could have we may be able to create different triangles because of the ambiguity of the information provided. Okay, so but we'll step through it we'll step through it case by case. Whatever we're doing today, we're just going to repeat the process tomorrow. So this is kind of a lot. So we're not going to do anything new tomorrow. We're just going to kind of practice this process that we're learning today. Okay, so we know law of sines, right? Now, there's different variations, right? Sometimes you may see the angles above, the sides below, but any variation is fine. Okay, so as long as we're consistent, that if we want to set up with the angle on top, everything else has to be on the angle on top as well. But you can do sides above and angle below, no issues there. Okay. Now we're calling this ambiguous case because there's this special circumstance where if you're given an angle, a side, and a side, these problems create this ambiguous case, meaning that we don't know exactly how many triangle solutions we may have. There may be one triangle, it may be no triangle, it may be two triangles. Now there's all these rules here, but I think I just want to be able to kind of show you, sketch the graph out, and if we just do the initial sketch, I think we'll be able to just reason it out and not have to worry about memorizing any rules or properties. Okay. All right, so I'm going to skip down to the bottom or to the middle of the page here. Now let's look at example 1. We have side A, side C, and angle C. We're always just going to focus on the angle. Okay, whatever angle is given, we're going to just draw it. I'm going to draw it the same way every time. That way we just make it familiar for every problem that we see. In terms of the accuracy of the angle, it doesn't really matter that much as long as you can differentiate between acute, right angle, and obtuse angle. That's good enough. Okay, and then in the meantime, we'll just try to do the best we can to estimate what we think is a 50-degree angle. Okay, but it really doesn't matter that much. Okay, always start with your angle. Now, sides A could be either here or here. Let's always put that here. Whatever side is given that's not opposite angle C, just always put it up here. That way we can just make every diagram as familiar as possible. Now the question is the side C. We don't know exactly where that side C is going to be. So we're gonna create something that is not part of our triangle, but will help provide an anchor for us to decide what's going to happen with our triangle. Okay. So this is not part of our triangle, but we're always going to create a right triangle out of this. So we're going to drop in altitude. And let's call this H. Again, this is not part of our triangle, but it will provide us very useful information as to how this missing side could be, or where that missing side C could be. Okay, we're going to solve for H. To solve for H, we can always use sine. So I can use sine of 50 is equal to what? Opposite over hypotenuse, H over 2. Now let's just solve for H. Okay, cross multiply. Okay, what's H equal to? 1.532. Okay. Okay, I'll put this over here. 1.532. Okay, everybody good so far? Now, there's a missing side C, but that side C has a length of 1, so I'm just going to put that over here. Is there any chance that this side C, so imagine that there's a pivot here, that this can kind of hinge, that this allows the side to kind of swing back and forth. is there any chance that we can create a triangle with this length? Too short, right? This is too short. Now, if the height was a little shorter, then maybe it has a chance. But this kind of gives us, this allows us to know that, okay, there's no chance that this can create a triangle because this is set in stone, right? This 50-degree angle is set in stone, and this is too short, okay? So what that means is there's no triangle out of this diagram, right? No triangle. Okay, there's all these rules and properties that we can memorize, but I feel like if we can just draw the graph out, we can just convince ourselves. Okay. Okay. We're going to look at other scenarios now where h has different length in reference and compared to the height. So we're just going to kind of observe all the different possibilities here. Okay, everybody good so far? Everybody in agreement that we just can't create a triangle out of that side length of 1, too short? Okay, number 2. Same thing. We're given a side angle and angle. We're always going to focus on our angle. Let's always put it in the same place. Make everything familiar. Whatever the unknown, whatever the other side is, you're just always going to put it above. Okay. We're always going to create this right triangle. It's not part of our triangle, but it will give us some much needed information. So we're always just going to target the height, the altitude of this pretend right triangle. Okay, let's solve for h. Again, use sine to set up. Cross multiply, solve for h. Let me know what you get. Okay. Okay, so 1.286. Now, the missing value is 3. Is there any place that this 3 can be besides out here? Okay, that's the only place it can be, right? Because if we can think of this as a hinge, there's no chance that this can be anywhere else, because we basically want to consider, is it possible for this side to swing over here and create a triangle here? There's no chance because this side is too long and it's not going to be able to land here as a height. So that's going to tell us there's only one triangle that can come out of this, and it's going to be out here because it's too long to either swing to this side, and it has no chance but to land out here. But we do get one triangle. Okay, does that make sense?
Put the B value on the side of the triangle for number 2, set A value on what side of the triangle. Does it matter?
Right, so you're always going to be given an angle. Always put an angle here on the left side and put the other side here. Always start with this information. And then we're always going to decide what to do with this opposite side from this known angle. Okay. So it could be angle C, it could be angle A, but I'm always going to start off my diagram with an angle and side. And then my decision is always going to be what to do with this last side. Am I going to be able to kind of swing it back and forth? But here, there's no chance for that. This is just going to be the only place that this, because it's so long, the only place it can land is going to be here. Okay. So now that we have our one triangle, so let's just write that when we say one triangle. We're now going to spend the effort to solve this triangle. So we're going to use law of sines, but this is going to be a little longer than the previous law of sines problem because we have some missing information that we have to deal with on the quiz. Okay. So, okay. We're not going to worry about that height, right? That is not going to be part of our diagram. Let me label all the missing sides and angles here. So this is angle B because it's across from side B. This is angle C. And then we also need to find the missing side C. Now we can't go ahead and find the angles because we only have one known angle. So well, we can still use law of sines. It's just that we have to solve for a different variable. My anchor is A because I have angle A and side A. But I'm going to target B because I have a missing information that I can solve here. So we'll say B over sine B is equal to A over sine A. Okay, cross multiply. Okay, 3 sine B equals 2 sine 40. Let's just get sine B by itself. What can we do? Divide both sides by 3. Use our calculator, 2 sine 40 over 3. .4285. Okay, inverse sine. Oh, so this is what's different, right? Here, if I want to solve for B, B is stuck inside sine. We have to do inverse, so we got to take inverse of both sides. We can't we can't divide by sine, right? We got to take the inverse sine of both sides. So that's what's different with what you saw in the quiz. In the quiz, you can find missing sides just by, because we have 2 known angles. Here, there's only 1 known angle. We have to kind of use inverse sine to get to our missing angle. Okay, what's angle B going to be equal to? Okay, 25.372 degrees. Okay, so now it gets easier. Okay, because if I could, now that I have 2 angles, how can I find angle C? Subtract from 180, yep. And once I have that, then it feels like a quiz problem. Now I can just set everything up and solve for my missing side C. Okay, so let's finish this problem here. So there's an additional step involved when you only have 1 angle, right? So we'll see this on the next page as well, but we have to involve inverse sine if we want to find the missing angle. But now that we have this angle, we can have an easier time. Okay, subtract from 180, I got 114.627. And now the last missing piece is side C. I'm going to pair C and and sine C, and I'll go back to using A over sine A. Okay. Shift that sine 114 over to the right side. Into the calculator. Solve for C. What do you guys get? 4.242. Okay, or 243. Let me see. Yeah, the more decimals you can include, the more accurate it'll be, but yeah, you're at 0.423. So either we can keep whatever number here, or we can round it up based off the next value. So either one's fine. Yes. You have to solve for the what? What do you mean the prime? I think we have everything, right? We have all three sides and all three angles. Okay, next page. Okay. Yeah, we'll deal with it. Okay, let's discover what's going to happen with this information here. Okay. All right, so start off the diagram the same way. We're going to just create our the left side of the triangle. We're not going to make a decision on what's happening with side A yet. We're going to drop the altitude here and just find that information, and we're going to see what's going to happen with this one. All right. Solve for H. Cross multiply, solve for H. Okay, what's H equal to? Okay, so H equals 4.589. Now, let's think about where could that side length 6 be? It's long enough where it can extend over to this side. All right, extend this out a little bit here. Is there another place that this side length 6 could be? Yeah, it could swing over here because it is between, it's longer than 4.589, but it's shorter than 8, so it has a chance to actually be over here as well. So we call this the ambiguous case because just based off of this information, it's possible that we could have an acute triangle or we can have an obtuse triangle. And because of that, we have to create those two situations and solve the two different triangles separately. Yes, question? Yeah.
Our side length is bigger than H, but then how come that one?
Okay, let's go back to that one. Number 2, you mean? So this is 3. 3 is greater than 1.286, but this 3 is too long. If we put it over here, it'll extend past this 40 degrees, and we would have to make this angle a little bit larger in order to accommodate for such a long side. So basically, this is only going to fit over here if it's larger than H but less than 2. So that's what we're looking for. Okay, that's what we're looking for. We want to look at this number in relation to these two numbers and see if it has a chance to be in a different location. And so that kind of helps me highlight what I want to say here is we want to look for that side length A. If that side length is A is between the vertical height and the hypotenuse for on the other side, then it has a chance. It has a chance to live over here as well. Okay, so we have two triangles. Let's go ahead and just put that down here, that there's two triangles possible. Let's do the one that's more obvious, right? So the one that's more obvious is the one that's out here. So we'll call that triangle 1. Sorry, I put that down. Okay, I'm going to carry a lot of information that I can bring over from this diagram here. So side 8, 35 degrees. This is angle A. This must be angle B, and this is angle C. I do have 6 here. Now we can fill that in. So just like the previous example, we're going to pair A and sine A, and then we're going to solve for angle B using law of sines. Okay, let's do that. Same setup as the previous problem. Okay, cross multiply. Get that decimal value, and then do inverse sine. Okay, what do you guys get for angle B? Okay. Okay, so that's the hard part. The hard part is just to get that second angle. Once you get that second angle, then everything is going to feel more familiar from the steps that you guys did on the quiz. Because once you find that angle B, you can use 180 degrees to help you get that final missing angle. Angle C. Okay, so we'll set up using law of sines to find that last missing piece that we need, side C. Okay, we're going to shift that sine 95.11 over to the right side, solve for C. Let me know what you guys get for C. Yeah. Okay, so that's one triangle. Give you guys a moment here. Okay, is everybody good here? Yes, question? Okay, so we're going to shift our attention over to the second triangle. But I do want to show you that done the majority of the hard stuff. We can actually carry some information over from the first triangle to the second triangle. But I want to show that to you first. Okay. Here's the diagram again. I'm going to draw this diagram just to kind of show how the two triangles can be linked together. So we had this, right? We had our triangle with the possibility of the side length here, but then also here. Now, I want to remind you of a property with isosceles triangle. If I have legs that are the same length, base angles are going to be the same. Okay, you guys good with that property? Now, do you guys see how this, I know this is not part of the triangle here, but if I cover this up, both these potential lengths are what? 6. Yeah, 6. Okay, what do we find from this angle, from the first triangle? Yeah, okay, so I'm going to just show that to you here. Do you see another 49.89 degrees somewhere on this diagram? Over here, okay. I know this is not part of a diagram, but I want to show you something here. Now, the triangle that we're after is this one right here, right, with the obtuse angle. If I can create this isosceles triangle with these two base angles that are shared, we can carry that over to here. Can we use this to somehow find this angle here? What's that relationship? Yeah, this is a linear pair, okay? That's a linear pair. So we can get to that angle quickly just by using this angle here. It doesn't seem very obvious, but I want to kind of show you that if you just understand that it's really coming from this isosceles triangle that we can draw. Okay, so basically once you get to this angle here, you can subtract from 180 to get to this angle there. Okay. So let's fill that in. What's that angle there? Mm-hmm. Okay, there's a lot of messiness there. I'm going to redraw the triangle below. So I'm going to carry information here because we know the 35 and the 8 are all the same. The 6 is here, and then now our new angle is 130.1. This is actually going to be an easier triangle because you have two angles. Anytime you have two angles, your problem will be a lot easier to work with. Okay, once you have two angles, how can I find this angle C up here? Yeah, subtract from 180. And once I have that, then I can use law of sines to find that last missing piece. Okay, what you guys get for angle C? Mm-hmm. Okay, so there's only one missing piece, right? Just have to find side C. Law of sines. Shift that sine 14.89 over to the right side. And finally, calculator. Okay, questions? Okay, there's a few more cases that we have to discover, but this is the hardest one. The hardest one is that the fact that you got that length that is long enough to be outside, but then also able to kind of swing to the other side and form an obtuse triangle. Okay, a few minutes left here. Let's just do some practice. But here on the practice page, we're just going to drop that altitude and figure out whether it's 0 triangle, 1 or 2 triangles. We're not going to solve. Okay, so we're just going to practice determining whether it's 0, 1 or 2 triangles, just to kind of get that practice in with finding that altitude and comparing that missing side, that hanging side there. Okay. So we'll just go as far as we can in 5 minutes, and I'm not going to assign any homework. We're just going to pick this up tomorrow. Okay. Okay, what you guys guess for H? Mm-hmm. Yeah, we'll talk about that. That's a good question. If your A value is your H value, that's going to force it to not only be one triangle, it's forcing it to be a right triangle. Good. Yeah, well, I think we'll see one of those examples show up. So H is 15.93, but my A value is only 11. So there's no triangle, right? There's no need to memorize any properties. You should be able to just convince yourself that I'm getting an A value that is not even as long as this height, so it's just kind of swinging back and forth without any segment to connect. So it's too short for a triangle, right? So say no triangles there. Yeah, so I think the case you're talking about, so let's discover something new here with number 2 here, number 2. Any question with 1? All right, so we're really not having to memorize anything, right? You're just convincing yourself that there's no chance for that triangle to be created with such a short side A. h equals 13. So what's different about this problem here? It's the same as the a value, which means that there's only one chance, there's only one thing that this a can do. It has to take on the exact value of 13, right? If it swings anything to the left or to the right, it's going to be too short. It's only going to land perfectly into a triangle if it lands right there. So in this situation, not only is it one triangle, we know it's going to be what type of triangle. There's no choice for this except for it to be a right triangle. Okay, so we're discovering all these possibilities, but I'm hoping that it doesn't feel like memorizing, right? You're just setting up your problem and you're just trying to decide what's going to happen with that side. Yes. Say it again. Oh, H is not really part of the triangle. It's there to kind of help us make a decision about what's happening with A. Is that? Oh, okay, number 3. Yeah, okay, so we haven't talked about this yet. This is an obtuse triangle. We'll talk about that tomorrow. Okay, so an obtuse triangle, it's easy, but we'll just cover that tomorrow. Okay, so we talked about the acute angles, obtuse angle. I'll go over those cases tomorrow, but again, you'll be able to convince yourself just by drawing the graph. Okay, so we'll stop there, and we'll pick up. No homework. We're just going to pick up where we left off tomorrow.
You showed us.